So in today's video, we are going to have a look at the percentage yield, what it is, how to calculate it, and basically everything about it. So before we understand what percentage yield is, let's talk about what yield is actually. So yield, like it's described according to the AQA GCSE chemistry specification as well, that it's the amount of the product that is obtained during a reaction. And when we compare this amount with the maximum theoretical yield as a percentage, we get percentage yield. Theoretical yield is the amount of the product that we expect to produce. And we can get this amount by using the balanced chemical equation, which we will talk about in a few minutes. But this is how we calculate the percentage yield. Now, you may be thinking that why do we have to calculate percentage yield? And that is because when we actually perform a reaction, when we actually do experiments in laboratory in real conditions, then not everything goes as we plan, and not all of the atoms of the reactants are converted, or not the entire mass of the reactant is converted into the product. And there can be many reasons for it. So one of it can be that the reaction was reversible. And so it didn't go to completion, which means that it never goes to completion, actually. So the products will break down to produce reactants again. And we will not get the expected amount of the product. And another reason can be that sometimes when we get different products, it may not be pure, and we may need to separate it. And during the separation, not all of the product is converted, or not all of the product is collected. So there may be some of the product may be lost at that time as well. And it can also be that there may be side reactions involved. The reactants may react in a way that we did not expect. The reactants may react with, for example, let's say oxygen in the air, and produce an oxide, or something else, which we were not expecting and which we did not want. So, which means that some of the mass of the reactants is actually ending up there. So, which would also result in a different or a lesser yield than we expected. Because of all these reasons, the actual yield, the actual amount of the product that we get during an experiment will never be equal to the theoretical yield, and it will actually always be less than that. So it's important that we are able to find out, that we know that how successful our reaction was, and what amount or what percentage of the product have we actually obtained. You can calculate percentage yield by a very simple formula. All you need to be able to calculate percentage yield is the mass of the product that is actually made. This will be your actual yield. You will also need maximum theoretical mass of the product, which is the predicted yield or the theoretical yield. And this is something that you'll not be given in a question. And then times it by 100 because we need to calculate it in terms of percentage. Now, the actual yield or the actual mass of the product will always be given to you in the question. Usually it is the theoretical yield that will not be given to you, and then you would be expected to find it. So if theoretical yield is not given, you will be given the mass of one of the reactant, at least one of the reactant, and using the balanced chemical equation, you can easily find out the theoretical yield. So let's have a look at this question here, an example question here, and let's see how to calculate the percentage yield from this question. So it says that in a certain experiment, 40.0 grams of potassium chlorate, KClO3, is heated until it completely decomposes. What is the theoretical yield of oxygen gas? The experiment is performed, the oxygen gas is collected, and its mass is found to be 14.9 grams. What is the percentage yield for the reaction? first of all, let's see what we are given. We are given the balanced chemical equation, and we are given the mass of the reactant, potassium chloride, AClO3. And we are asked to find out the theoretical yield and then the percentage yield. So this question has two parts to it. Also, it says that the mass of the product, the mass of oxygen gas collected was 14.9 grams. Now be very careful that this 14 grams is actually the actual yield. It's the actual mass of the product that is produced during a reaction. So this is something that we'll be needing at the very last step. So yeah. First of all, the balanced chemical equation is given to us, and it says here that we have 40 grams of potassium chloride. We have 40 grams of the reactant. And we need to find out the theoretical mass of the product, which in this case is oxygen. We do not have the theoretical mass or theoretical yield. Actual yield is given, 14.9. Theoretical yield is not given. Theoretical mass of the oxygen produced during this reaction is not given, which means that we have to find it out. Instead, what is given to us is the mass of the reactant, which is 40 grams. So now the point is that how do we go from the mass of this to mass of oxygen? We can do this in very simple 3 steps, and whenever questions like these are given to you, your first step would always be to use the mass of the reactant to find out the moles of that reactant. And then in the second step, you will find out the moles of oxygen gas. And this is the step where you will be needing balanced chemical equation and the molar ratio, because we need the molar ratio from the balanced chemical equation. So this is the step where you'll be using the balanced chemical equation. And once you have the number of moles of oxygen, you can easily calculate the mass of oxygen from that amount as well. And this mass will be your theoretical. And then you'll plug it here and we'll easily be able to find out the percentage yield for this reaction. So let's actually do it. In the first step, you're going to use the mass of potassium chloride, which is 40 grams, and divided by the molar mass of potassium chloride, which is 122.55 grams per mole. Do the calculation, and it's going to give us 0.326 moles. Now, using the number of moles of potassium chloride, we have 0.326 moles of potassium chloride. And this is a step where we need to use the balanced chemical equation, because according to the balanced chemical equation, you can see that the molar ratio is 2 to 3. The molar ratio between potassium chloride and oxygen is 2 to 3. So we have 2 moles of potassium chloride and then 3 moles of oxygen. Now we are writing, you would want to write potassium chloride, moles of potassium chloride at the bottom in the as the denominator, because then this and this would cancel, and then you'll only be left with moles of oxygen. So you solve this and it gives you 0.489 moles of oxygen. Now that we have the moles of oxygen, we are only left with one last step, and that is to find out the mass of oxygen. So all you have to do is multiply the number of moles with the molar mass, and that would give you 15.6 grams. Now this is our theoretical yield. All we have to do is just plug this information, write down these numbers, substitute these numbers in the equation, and then we'll get the percentage yield. So the percentage yield will be 14.9 grams was the actual yield, which was already given in the question, and then 15.6 is the theoretical yield that we just found out, and times it by 100, and then it gives you 95.5%. Here's another question. You are given the percentage yield, which is 92.8%. And we know that the maximum theoretical mass of sulfuric acid that we can obtain is 12.5 grams. It's the theoretical mass of the product, so it will go here. And we do not know the actual mass of the product, which is also something that we would need to find out. And then we can just write mass produced, because this is something that we do not know, and times it by 100. And you need to just rearrange the equation so that mass produced is the subject of the equation. So the equation would become mass produced equals 92.8, and then times by 12.5, and then divided by 100. You solve this, and this would give you 11.6 grams. And that is our answer. That is the mass of the salt that is actually produced. Again, you have to be careful about the marks of the question here, because it's a 3-mark question, which means that you require all these 3 steps. And you can see it in the marking scheme as well, that you'll get 1 mark for substituting the values. You will get another mark for rearranging the equation, and then another mark for correctly finding out the mass. And this is how you get your 3 marks. So this is all for today's video. If there's anything else that you want me to explain, you can write it in the comments, and don't forget to like, subscribe, and share. Thank you very much.